Hello, everybody. Welcome back to Mathlete's Corner. Today, we're going to be doing some geometry. We're going to discuss angle chasing. So, let's just start with this warm-up problem from 2024 State Sprint Problem 15. In triangle ABC shown here, point D is on side AC such that AB equals AD, and angle ABC minus angle ACB is 30 degrees. What is angle DBC? So that's a lot of information. So let's try assigning some variables and see where we go. So we know that AB is equal to AD. So let's say that angle ABD and ADB are both equal to X. Those two angles need to be equal because ADB is an isosceles triangle. Now we can say that BDC is 180 minus X. Let's write that down here. 180 minus X. Now we're stuck again. We don't know what to do. We can't make any more progress from here. So let's look back at the question and what we want to find. They're asking for the angle of DBC. So let's assign another variable to DBC. And let's call that Y. Now we can use the information we're given here that ABC is 30 degrees more than ACB. So what does that mean? That means that angle ACB is equal to X plus Y minus 30. Now, we can add up the angles of triangle, let me highlight this, triangle DCB. We can add up the angles of that triangle to get a total of 180. So let's do that. X plus Y minus 30 plus Y plus 180 minus X is equal to 180. Now we have an equation that we can solve. And remember, we want to find Y. So when we add this up, we'll notice that the x's cancel. And we get the equation 2y plus 150 equals 180. Subtracting 150 from both sides gives 2y equals 30. And finally, we can divide both sides by 2 to get y equals 15. And that's our final answer. So here we see that the fundamental idea of angle chasing is assigning variables to angles and using the variable to find other angles. Now, before we keep going, let's just discuss this theorem. This is called the inscribed angle theorem. So, what does the inscribed angle theorem tell us? So, say we have this circle here, and say that O is the center of that circle. Now we have points A, B, C, D, and E on the circle. So the inscribed angle theorem tells us that AOB is 2 times ACB, 2 times ADB, 2 times AEB, or 2 times any angle that subtends arc AB. Now, the corollary that comes from this theorem is that ACB, ADB, and AEB are all equal. So let's keep that in mind as we do the next question. In regular octagon A, B, C, D, E, F, G, H, find the measure of ACF. Alright, so in any geometry problem, it doesn't have to be angle chasing. It's probably best to start by drawing the diagram. Then we label the vertices. And then we look at what we want. Find the measure of angle ACF. So let's draw that angle in. And we want to find that angle. Well, we don't have any formulas for this angle, but we do have the inscribed angle theorem. The only problem is the inscribed angle theorem is about circles. We don't have any circles. What we do have is an octagon, not just any octagon, a regular octagon. Since the octagon is a regular octagon, we can draw a circle that goes through all 8 vertices. Alright, should go through this point too. Okay, not the best circle, but it'll do. And now we see that ACF subtends minor arc AF. So all we need now is the number of degrees in minor arc AF. And since the octagon's sides are all equal, which is because it's a regular octagon, by the definition of being a regular octagon, all the sides are equal, and so the arcs that correspond to each side must also be equal. So we see that minor arc AF, what we're looking for, minor arc AF over 2 is equal to 3/8, and that's because there's 3 sides going from A to F. 3/8 of 360, and then over 2. And now we have something we can evaluate. So let's do just that. And we get 135 over 2. And since it's degrees, let's express it as a decimal. 67.5 degrees. Alright everybody, thank you for watching. Don't forget to hit that like and subscribe button. I'll be posting every Sunday, so we'll see you next time here at Mathlete's Corner.